Hi, the topic for this video is solving linear equations. By now you can identify linear equations, but now you want to solve them. And what does that mean? You want to generate solutions to linear equations. But what is a solution? Well, a solution to an equation involving a single variable is a particular value for that variable which causes the equation to be satisfied. Just hold on. An equation is satisfied when its left-hand side is equal to right-hand side. So I'll give you an example of an equation involving a variable. The equation x equals 3. This is the left-hand side and this is the right-hand side. This is an equation involving a single variable. And if I now ask you to solve this equation, I'm telling you to find a value for this variable x that causes the left-hand side of this equation to be equal to the right-hand side. So consider the left-hand side and right-hand side separately. In this equation, the right-hand side is 3. For the left-hand side to equal the right-hand side, x must have a value of 3. When x has a value of 3, the equation is now 3 equals 3. And the left-hand side is equal to the right-hand side term. Therefore, the equation is satisfied when x is 3. But the key thing to note is that a variable can take multiple values. The variable x, as it stands here, stands for any value. It can be 1, 2, 3, 4, 5, 6, minus 8, 0.78. But what we're just saying is solve this equation, meaning determine a value for x out of the numerous values it can take. Determine a value for x, the variable, that will cause the equation to be satisfied. That will cause the left-hand side to equal the right-hand side. That is what solving an equation means. But we're only going to be focusing on solving linear equations, equations that you've seen in previous videos, equations of the form y equals mx plus c. Now I'm going to use these three equations to illustrate the concept of solving equations. Now, and like I said earlier, we're focusing on linear equations, equations of the form y equals mx plus c. And I'm going to need you to accept that each of these equations are actually of this form, even though it's not obvious. I'll demonstrate this fact with using just this equation. This equation is the instance of this form where m is 0 and c is 9. Because if you substitute or you replace m with 0 and c with 9, in the general form you get 0 times x plus 9, which is 9, because 0 times x is 0. 0 times anything is 0. As you can see, and the same applies for this other equation. But that's not our focus. Our focus is on understanding what it means for an equation to be satisfied. Now, in this equation, you have a left-hand side and a right-hand side term. The right-hand side term is 9. The left-hand side term is a variable y. And being a variable y, so forget about this, y can take many values, ranging from minus infinity, or let me just say, can take values like minus 99, 9, 10, any number you can think of, to be honest. But what value of y causes this equation to be satisfied? What value of y causes the left-hand side of this equation to equal the right-hand side? Well, when y is 9, so if I say y is 9, the left-hand side of this equation is now 9, and the right-hand side is 9. Therefore, when y is 9, this equation is satisfied because y will be equal to 9. The left-hand side will be equal to 9. 9 will be equal to 9. If y was 8, the left-hand side would be 8, but the right-hand side would be 9. They would not be equal, and the equation will not be satisfied. So this equation is only satisfied when y is 9. Moving on to this equation, x plus 1 equals 4. What value does x take? Because x is a variable, it can take many values. What particular value of x causes this equation to be satisfied? Well, the answer is 3. When x is 3, the left-hand side, as you can see, this whole term here, which is x plus 1, becomes, instead of x, 3 plus 1, because this is the case where x is 3, which is 4. And the right-hand side is just 4. As you can see, when x is 3, the left-hand side is 4, and the right-hand side is 4. If x was another number like 4, if x is 4, the left-hand side would be x plus 1, which is 4 plus 1. The left-hand side will be this, and that's 5. The right-hand side of the equation will still be 4. When x is 4, this equation is not satisfied because the left-hand side and the right-hand side do not match. And now to a final example. The equation y minus 3 equals 5. The solution to this equation is a value for the variable y that causes this equation to be satisfied, that causes this left hand side to equal the right hand side. Now I'm not going to say the answer, I'm just going to try a number randomly. When y is 6, what's the left hand side term? The left hand side term is y minus 3. Since y is 6, it's actually 6 minus 3, which is equal to 3. So our left hand side term is 3. Our right hand side term is 5. Is the left hand side term equal to the right hand side term when y is 6? No. Therefore, y equals 6 is not the solution to this equation. What about when y is equal to, say, 8? When y is 8, what's the left hand side term? The left hand side term is y minus 3, which is 8 minus 3, which is equal to 5. The right hand side term is 5. So when y is 8, the left hand side term of this equation is equal to the right hand side term when y is 8. But when y is 6, that's not the case. So y equals 8 is the solution. So now you understand that a solution to an equation involving a single variable like the ones I've shown you is a value for that variable that causes the equation to be satisfied. And if you remember from the definition I gave earlier, an equation is satisfied when the left hand side term is equal to the right hand side term.